David and Katrina have a small farm and they wish to fence off an area of their land so they can raise sheep. The area they have chosen has one border along a road as shown in the diagram below. The enclosure is shown as the shaded area above and has right angles at points F and G. David and Katrina want the combined length of the fencing from E to F and F to G to equal 500. So looking at the diagram, that's telling me that P plus Q is equal to 500. So let the length of EF be equal to P. We've seen that on the diagram, and the length of FG be Q. If we locate the origin at F, and the x-axis is along FG, the equation defining the fence along the road is given by this. Show that the equation defining the area of the enclosure can be given in terms of Q as follows. Well, the area would be the integral from 0 to Q of 10 sine x over 15 plus P dx. So that's going to be, so we know that sine integrates to negative cos. So that's going to be negative 10 cos x over 15 divided by 1 over 15. Remember, that's a reverse chain, plus px to go from 0 to q. Okay, so that is going to be, so dividing by that 15, that's going to give us negative 150 cos x over 15 plus px 0 to q. Okay, let's see what that gives us then. With the top limit, that's negative 150 cos q over 15. That's that bit of the equation, so that's nice. And then we've got plus pq. And then with the bottom limit, that gives us minus 150 cos 0. Okay. So that is going to be, maybe use here, got a bit more space. So I've got negative 150 cos q over 15 plus 150 for that bit there, so minus minus, cos 0 is just 1, plus, and this expression just has q in it, so it's going to be q, and p, of course, is 500 take away q from what we discussed right back at the beginning, that p plus q is equal to 500. So that's going to give me, when I expand that out, that's the 500q. I get the minus q squared. I've got the minus 150 cos q over 15 and the plus 150. And that's everything that's required there. Okay, determine to the nearest meter the value of q that will allow the sheep to graze over the maximum area, and state the maximum area. Okay, so we could probably use the calculator to do some of this if we want to. We want dA dq. That's going to be 500 minus 2q. So this negative cos will differentiate to sine. So that's going to be plus, and that will end up being 10 sine Q over 15, and the 150 of course disappears. So when we differentiate it, we multiplied by 1 over 15, which is why this is 10. So dA and dQ equals 0 means, this is where we really do need the calculator. So we've got 500. Oh, let's just action, advanced, solve. 0 equals 500 minus 2x plus 10 sine x over 15. And that's given us 246.65. Okay. So, and that's equal to 247 meters because we were asked to the nearest meter. And so the area will be, so we have got 500 times this answer, take away answer squared, take away 150 times the cosine of that answer divided by 15, and 150. 62750. Okay. The length of the fence from E to H is given by the equation shown there, where r dash x is the first derivative of r of x. Now, probably need to go back and figure out what r of x was. There we go, 10 sine x over 15. That's p. Let me go back and check that. 10 sine x over 15 and p. There was a 10, wasn't there? Yep. So it was that. So r dashed, sine differentiates to cos. So it'll be 10 cos x over 15. The p is just a constant, that'll disappear. Chain rule, we need to multiply by 1 over 15. So that is going to be 2/3, 10 over 15 cos x over 15. Hence determine the total length of the required. So that's going to be the 0 to the 246.65 of the square root of 1 plus 2/3 cos x over 15 squared dx. So calculator paper, we are just going to integrate that. So we're going to go from 0 to 246.65. And that will be the square root of 1 plus and then we've got 2/3 the x. 272.86. So the total length of fencing is going to be that 272.86, which goes along the roadway. Added 2. We need 1 Q because that's opposite the roadway. And then because P and Q add up to 500, this would be 253, and so that would be 253 as well. So we've got the last answer, add 247, add 2 lots of 253, which is 1026.